right, good morning. Let's start. All right, so we were on the adrenal gland, and we talked about the first zone, the most superficial part of the cortex, the most outer layer, in other words, of the adrenal gland. All right, now we're on the middle one, and the middle zone is called zona fasciculata. And it makes glucocorticoids. So the zona glomerulus made mineralocorticoids. This next one makes glucocorticoids, which we know as steroids. I shouldn't use that word steroids. Steroids is more encompassing than that, but by steroids I mean steroids that you typically think of, like hydrocortisone. I'll give you some example. Cortisol, hydrocortisone, prednisone, Medpac, things like that, right? For example, that's one of the newer things that they're giving for COVID infections, right? So, they're giving prednisone. Not for everyone, but for some people. Right, so that's an example of a steroid. So there is no long pathway that we have to follow. I just want you to know what steroids do, and that's it. So this one's going to be a lot easier. So what are the functions of steroids? Well, they are, in high doses, they're immunosuppressant. So if you give them in high doses, they suppress the immune system. So you'll see people that have had operations or people that have, can't think of any other words today, autoimmune disorders. They might be on some kind of steroid. So they can be immunosuppressant. I'll put that as 1. They help you deal with stress. All stress. Physical stress, emotional stress, stress. Three. So they repair tissues. So we're going to go back to the same things we talked about with T3, T4, and human growth hormone. So we have this idea of glycogen breakdown. There's 2 ways you could say it. When you break down glycogen, you're adding blood glucose, right? So it's adding glucose because we're going to break that down into ATP. Then we have our old friend lipolysis. that's for fats. And then we have, oh good, gives me time to think. Then we have amino acid use. So increased amino acid use, which is the same thing, that's the same thing as saying increased protein use, right? You're increasing the amount of proteins you get from your food, and you're using those proteins, in this case, not necessarily to grow, but to repair things. Oh, I remember the sixth thing that I forgot. It's anti-inflammatory. Which is an extremely common use for steroids. I don't know why I didn't think of it earlier, but so 3, 4, and 5. We've seen that before. That's the same thing the human growth hormone does, pretty much. Same idea, right? You want to increase the amount of sugar and fat, because those are two forms of energy, right? Sugar is your short-term energy, fat is your long-term energy. Or I could say it a better way. Glycogen is your short-term energy, and lipids, triglycerides, are your long-term energy. However you want to say it, fat, triglycerides, lipids, it's all the same thing, right? Or here I'll say sugar, carbs, glucose, glycogen, that all means the same thing, right? So you've got sugar, that's short term, that's going to last you like a day. If you don't eat any food, it'll last you a day. And then you got fats, that's going to last you longer. Your body uses both of those as energy sources. So number 3 and number 4, that's to make ATP. We're going to take that ATP, and we're going to use it to make new proteins, because we have some kind of tissue to repair. So 3, 4, and 5 you've seen before. 1, 2, and 6. I know I worded it weird. That's new. Right? So immunosuppressant in large doses. It helps you with mental stress and emotional stress and physical stress. And then it's anti-inflammatory. That's what steroids do. That's it from that zone. So that's that middle layer of the cortex. Good? Can you guys see the bottom? Well, you can't see it, because I can see on my screen, it's kind of hard to see. Anti-inflammatory. And now I shall erase it. Beautiful. It's going to bug you, not me. All right. That's the middle layer, zona fasciculata. Now we are on the inner layer of the cortex, which is called zona reticularis. Could have left that word on there. They make a class of chemicals called androgens. The only androgen that I'm going to want you to know is called dihydroaldosterone. Luckily, because I don't even know if I said that right, we're going to abbreviate that. Dihydroepiandrosterone. All right. DHEA. Because nobody calls it the whole name. DHEA. So we're talking about the inner layer of the cortex. They make androgens. So you might be thinking like androgens, androgynous, something like that, right? So now you're thinking like sex hormones maybe, and so you'd be on the right track. Right, androsterone kind of sounds like progesterone, androsterone, testosterone, right? So it's related. So DHEA does a couple of things. And we think that it's related to libido, which I can't remember how to spell. I think that's how it's spelled. You can look it up. You have phones. So it contributes to libido, probably not in men, but in women. And then it's related to estrogen. So it's related to estrogen. So the thing about sex hormones, and I'm simplifying it here. I'm not being entirely truthful, but because you know why? Because people really don't know about the endocrine system, right? You're just getting a little bit, and you know there's books like this thick on the endocrine system, but at the end of the day, people don't know more than we do know. The only difference between me and you is that I know I don't know this stuff. You might think that it can all be learned. I know it's impossible. But anyway, so our best idea is that, let's take, for example, estrogen and testosterone, right? Estrogen is for women and testosterone is for men. Men have estrogen. Women have testosterone. But I mean, this is one way to look at it. The estrogen is like dominating the testosterone and like suppressing it and holding it down in women. So if something were to interfere with estrogen production, then now you would see testosterone manifest a little bit more. Some people have problems with their adrenal gland. They call it like adrenal hyperplasia, right? And so one of the effects, so if you imagine that there's something wrong with your adrenal gland, if there's like a tumor messing it up, then now you think about these different layers. Usually this affects the zona fasciculata and it affects this one. So let's talk about this one first. So if you mess with the zona reticularis and you mess with the androgens, you're not going to make as much estrogen, meaning that you would make more testosterone, or like the balance would shift towards testosterone. So you would have something called like what they call pseudomorphism, like you would get hair, a little bit, whatever, hair in your face. That would be a sign. Maybe you could trace that back to the adrenal gland. And if you think about steroids, so if you mess with steroids, you're going to see, like emotionally and even physically, you couldn't handle stress. I mean, beyond what's normal. Right, so those would be two signs that something's wrong with the adrenal gland. So in any event, this is, that's it. That's what the zona reticularis does. That's much easier than the first one we talked about. So that's the cortex. That is the cortex of the adrenal gland. Zona glomerulosa, zona fasciculata, zona reticularis. Now we're in the middle, all the way at the core of the adrenal gland. That's the medulla, the deepest part of the adrenal gland. Oh. Hold on, it's bugging me. I admit it. All right. We're at the medulla. The medulla makes a class of chemicals that are referred to as catecholamines. Just like an FYI, when you see a CH followed by a vowel, it's not always the case, but like when you see it in anatomy, medical, whatever, right? Pronounce it as a hard K. So it's like cold, right? It's all the words that have, I don't know. Anyway, so this is two examples of this which are relevant to the medulla are epinephrine and norepinephrine. Going to grab my coffee. So I know a couple of you were kind of like annoyed at the camera. It keeps focusing and following me. If you guys decide as a class that that's not working, you don't like the camera following me, then I can move next door. That camera will stay fixed in one position. It's just weird because the camera like comes in at the side. Like you probably saw it in another lecture, the last lecture. Wednesday I used it. So whatever, it's up to you. I got both classrooms I can use. So I know I walk around a lot, so. So adrenaline, noradrenaline, that's what it used to be called. So let's talk. So for now I'm going to treat them as I'm going to treat them together. I'm going to put them together. Right? There are subtle differences between the two, but for now I'm just going to put them together. Oh, it's adrenaline. It's your sympathetic nervous system. I mean, norepinephrine is like a neurotransmitter in its own right, and so you'll see stuff about that. But for now, we're not on the nervous system. So it's a hormone. These two are involved in fight or flight, your sympathetic response. And so think about what you need to do with your fight or flight. You need to flight. That's what I would usually do. I'm not going to fight a grenade or a snake. I'm going to run. And so what do I need to do? I need to get my leg muscles running. So I have to get energy down there. I have to get energy down to my legs. So I have to get my heart pumping fast. So increase heart rate. Obviously, I want to increase heart rate. And I want to dump glucose into my blood because I need to get that glucose down to my legs. I need to make ATP, like now, right? So increase is there lipolysis? I don't remember. Maybe. I'm thinking no, because that might take longer to process. This is pretty quick. I mean, I don't need adrenaline in 20 minutes from now. I need it in about 5 seconds or less. I need it now. Right, so I don't know. But I know this, you know, you got to get ATP from somewhere. So we're going to get it from blood sugar, maybe or maybe not fats. There's no proteins involved here. This is your fight or flight response. You don't need to make proteins. Your body can care less about digesting food or peeing or making proteins to repair things. You just want energy to get out. Now you'll see these two throughout the semester because they do other things, like epinephrine can constrict blood vessels, and it also dilates your bronchioles. It's a bronchodilator and a vasoconstrictor. And it works to raise blood pressure, right? If somebody's in shock, this is kind of a common thing to get. So you'll start giving epi to somebody whose blood pressure is plummeted, right? And you also give it to little Jackson because little Jackson has a peanut allergy. So the whole damn class can't use peanut butter. Now you as a parent got to find some shit to put on the sandwiches other than peanut butter, and half the lunch stuff out there has peanuts in it. But little Harrison or little Clinton or little Washington has a peanut allergy, alleged peanut allergy. I would really like to test it out one day. But anyway, that's what epi does. Epi, norepi, right? So I'm kind of putting them together. And I didn't mean to throw shade on Jackson. He's probably a nice kid. Just, I don't remember so many peanut allergies. But that's what he gets. Give him epi. All right, that's the adrenal gland. The hardest part of that was the part from last class, the renin-angiotensin-aldosterone thing. Make sure you know that. Make sure you know the functions of steroids. That'll be another question that I ask. I'm unlikely to ask about this because that's it, right? And we talk about epi. I mean, this gets talked about all the time. So I'm unlikely to ask about this. I never ask about DHEA, but it is something you'll see. All right, all the things that I wrote, you'll see them in other classes or in real life. You'll run into that stuff. DHEA is a common lab that they do on people. This is all the time. But I'll talk about it in other chapters. So that's the adrenal gland. Are there any questions so far? I see the camera. There's only like one person watching, and you two. Everyone else turned on their computer and they went to bed. They're gonna watch the recording like tomorrow night. It's not gonna happen. You're not gonna watch the recording. All right. Any questions? Let me look at the chats. See if there's anything. No. All right. I'm gonna move on. So we talked about thyroid. I'm not going to walk over there to read the comment, because it might be just your name. I've been burned too many times. So if you guys have a question, just unmute yourself, throw it in there. What's that? You guys hear something? Now I'm going crazy. All right, pancreas. Let's talk about the pancreas. So, pancreas Trying to think if I have anything else that I want to talk about besides the pancreas. I think that will be the last hormone. The last thing I want to talk about. Right? Anything else that's in the book or that's in the video I made is, you could study it on your own. But another question I will ask is about the pancreas. So before I get into it, I just want you to understand the idea behind glycogen and glucose, and we've already talked about this. So I'm kind of repeating myself here. You have this exchange, or not an exchange, but your body's constantly making glycogen and constantly breaking up glycogen. So glycogen, which is, again, it's stored, glycogen is stored in your liver and your muscles. Glucose is in lots of places, but in your blood, amongst other places. By the way, this is a little FYI. Your body uses only ATP for energy, but there is an exception to that, your brain. Your brain does not use ATP. Your brain uses glucose. So that's why you need carbs. So those of you on a protein diet, Atkins diet, keto diet, don't forget your brain needs a lot of sugar. So, and kids, man, give kids something to eat. I sent my kid to school with a can of root beer because I just didn't have my shit together, which happens. Any of you parents, you know that it's the truth. And, I'm like, okay, well, it's root beer, but it's sugar. That'll keep him going for a couple hours. I don't want his brain to, they run out of glycogen in like 4 hours, right? So that's why they have snack time, and that's why lunches are so important at school, right? Or that's why they have the breakfast programs, right? Because it's important that kids, especially, they have some kind of sugar so that they can keep their brain going. Otherwise, they start getting all ADHD type, right? And so sometimes this is just not eating breakfast or not eating properly in the morning, right? This leads to this hyperactivity type of behavior. I'll tell you what else leads to it, being a kid, but whatever. Can't keep a kid inside all day. I'm talking to myself as parents. Keep our kids in there all day. And then, little Harrison's, these kids have the last names of presidents. Little Harrison has hyperactivity. He's not like sitting at his desk. No shit, he's 8. He wants to go in a room with all these other kids and like run around. But it's not organized play. Yeah, they don't care. It's my generation's fault. Sorry, you younger people. Not to say that there's no ADHD, there is. But what I'm saying is, give your kids breakfast, even if it's a can of root beer. Give your kids root beer for breakfast. That's what I'm saying. So, that root beer is going to go into little Harrison's blood, and he's going to start storing that blood sugar, because that's way too much sugar to give your kid. What the hell's wrong with you? So you start lowering your blood sugar and putting that as glycogen, storing it as glycogen. And what's the hormone that lowers your blood sugar? You're right. Nobody. Insulin. So that's one of the hormones of the pancreas, insulin. There is a hormone that's going to break up glycogen. Glucagon. Glucagon raises blood sugar. Insulin lowers blood sugar. How? By either making glycogen or by breaking up glycogen. So if we talked about epinephrine, is that in any way related to glucagon? Yeah, because if epi is going to be released, you're going to have a bunch of this released because I want to break a bunch of this up. I want sugar in my blood. I want high blood sugar. But anyway, keep our blood sugar somewhere. Everybody has different numbers, but somewhere around, let's just say 100 to make it a nice easy number. 90 to 100, something like that. Everyone's got different opinions. If your blood sugar goes down to like 60, that's really low. And I've seen it at high, where like the glucometer can't measure it. It's like 500 or something, right? It goes to a certain point and it's just like, right, so. Anyway, these are two of the hormones that your pancreas makes. Your pancreas makes 4 hormones. Your pancreas is an endocrine gland and an exocrine gland. Your pancreas is located, your stomach's here, so you kind of lift your stomach up and you're going to see it underneath. We're going to try to, we'll try to dissect something this semester, and then I can kind of show you what the pancreas is. But when you feel pain in your pancreas, it's often like in the middle. So pancreas is like here. Maybe I'm too high, I don't know. It's here. There's 4 different types of cells. I'm not going to give you the cells anymore because you guys all memorized the cells and not the hormones. So there's 4 hormones. We already have 2. Glucagon, insulin. Glucagon raises blood sugar, blood glucose. Insulin lowers blood glucose. We have a third. You'll see maybe like on the HESI test, they have questions and they ask about the cells. So these are alpha cells, these are beta cells. That might be on it won't be for me, but that might be on a test for like an entrance exam for nursing or something like this. Alpha cells, beta cells. And don't screw it up and say that insulin's the alpha cells, which is like what people do. So alpha cells, beta cells, all right. Then we have a third hormone called somatostatin. You remember that word? It was before. I mentioned it briefly, just briefly, so I wouldn't blame you. Somatostatin is also known as, take a sip of coffee, build up the suspense. Growth hormone, inhibiting hormone. So your pancreas also makes somatostatin to kind of slow these 2 down. I don't remember why it does it, but somatostatin stops secretions of insulin and or glucagon. Alpha and beta. The last one's called pancreatic polypeptide. Your pancreas makes a bunch of enzymes that break down your food. That's an exocrine function, meaning that it goes through a duct. It doesn't go into your blood. These go into your blood. The enzymes that the pancreas makes goes through a duct and into the intestine. So this stimulates the release of the digestive enzymes. So we're going to talk about the pancreas twice in this semester. Once now, and one's for the digestive system. For this class, for now, we're done. That's all the pancreas, that's the four hormones the pancreas makes. What people often do is they remember the first two and they forget the last two. So make sure you know this one and this one. So I'm going to ask you, what are the hormones of the pancreas and what are their functions? I want you to know what they are and what do they do. You don't have to remember the signs. You could just write this. They stop these secretions, however you want to put it. I don't care that you remember that it's GHIH, it's okay. But that's the pancreas. And that is, that's pretty much the end. I mean, there's the pineal gland that I'm not going to ask you about. Testes and ovaries. I mean, I think you know what those make. We're going to cover them under the when we talk about the reproductive system. There are some other hormones like leptin and gastrin and stuff like that that we'll cover in other chapters. So you might see some other hormones at the end of the chapter. For those of you that are reading the book, I'll cover them in other chapters. So this is the end of the endocrine system. It was a rather hard chapter, especially compared to the one that we're going to go into now, which is blood. So, does anyone have any questions on anything in the endocrine system? That's a question. The functions of steroids, that's a question. The whole renin, angiotensin, aldosterone, that's a question. Okay. Okay, another another heart medication, another blood pressure medication. Beta blockers. Beta blockers block the receptors for epinephrine. So so your body's not acting on epinephrine. Epinephrine is going to speed heart rate. It's fight or flight, but we're making epinephrine now in small levels. It is influencing our heart rate, right? Now, and if your heart rate goes up, your blood pressure is going to go up. So if we can block epinephrine, we can keep our heart rate down and keep blood pressure down. So that's another way. You can hit it with ACE inhibitors. You can hit it with diuretics, stuff that just makes you pee more, just on your own, water pills. And third way, you can hit high blood pressure with beta blockers or something like that, something similar. Something that blocks epinephrine or norepinephrine. So those are three common things you'll see because everybody's got high blood pressure. And it's only growing more than everybody is going to have high blood pressure in the future. All right, I'm going to stop recording this one, and then I'm going to hit record again and start on blood. Just give me a second.